Hello everyone, I am Priyotos Pradhan. I am doing my PhD from Metallurgical Department in IIT BHU Varanasi. In this class, we are going to learn about X-ray diffraction and Bragg's law. So we are going to cover on the following topics, starting with basic X-rays, its interference and diffraction, and finally the Bragg's law of diffraction for X-rays. So X-rays were first discovered by Wilhelm Röntgen in the year 1895, and he got a Nobel Prize in 1901. At that time, the properties of X-rays were quite unknown, so they gave the name X-rays. By the time 1912, the properties of the X-rays were established. Max von Laue, he first predicted the X-rays can diffracted by crystals, for which he got a Nobel Prize in 1914. In the same year, in 1912, William Lawrence Bragg and his father, William Henry Bragg, they gave the famous theory of Bragg's law, and this gave him another Nobel Prize in the year 1915. So, what is X-ray? X-ray is an electromagnetic wave with wavelength ranging from 10 to the power minus 2 up to 10 to the power 2 angstrom. I hope everyone knows how much is 1 angstrom. Can anyone say it? Okay, 1 angstrom is 10 to the power minus 10 meter. So if you see the electromagnetic spectrum, X-ray lies in between gamma rays and UV rays. So it is also interesting to know that the range of X-rays and the gamma rays, they overlap. So that means there is a portion of wavelength which comes under gamma rays as well as X-rays. So this X-rays or gamma rays overlapping region. So how do you distinguish if it is a gamma rays or X-rays? This can be distinguished by the origin of the electromagnetic wave. If it is a electronic origin, then we call it X-rays. If it is a nuclear origin, we call it a gamma rays. So back to the topic. So like any other electromagnetic wave, X-rays also follow the following rule. C equals to lambda multiplied by nu, where c is the speed of light in vacuum, lambda is the wavelength, and nu is frequency. And the energy of each photon of X-rays is given by h multiplied by nu, with h is the Planck's constant and nu is the frequency, which is also equals to hc by lambda. So higher the frequency, higher will be the energy. Another interesting property of X-ray is that this is invisible and it can penetrate most of the material. This property we use for medical applications. So in medical application for imaging of broken bones, we use soft X-rays. Then another application is the X-ray crystallography. As we know, the crystalline materials, they have a periodic arrangement of atoms. So this arrangement of atom, we call it crystal structure. So this crystal structure of material can be analyzed by X-ray crystallography. And another application is X-ray photoelectron spectroscopy. Here, the chemical composition of a material can be analyzed, like which elements are present and how much amount we can analyze by this method. So let's learn about interference and diffraction. So before that, we should know something about superposition. When there are two waves present in the same space, those two waves combine and they exhibit superposition. If there are two waves near one another, they tend to superimpose and the resulting pattern is called interference pattern. Few things can happen when interference occurs. So if two waves, they are perfectly aligned, that is the crest to crest and trough to trough, they are perfectly aligned. When that interference occur, the resulting amplitude will be twice as that of the constituent wave. This is called constructive interference. On the other hand, there is another type of interference which is called destructive interference. Here, the crest of the first wave align with the trough of the second wave and vice versa, and the resulting interference pattern is a total Darpa pattern. So we can see both the waves, they annihilate each other. This is called total destructive interference. Now let's learn about diffraction. Diffraction is the phenomenon of bending and spreading of wave at some obstacle. The obstacle, it can be in the form of a edge or any slit or a number of slits. If you can see the image, at the edge of the obstacle, the light wave tends to bend. Similarly, in case of a slit or a pinhole, the input wave is spreading out. And similarly, in case of a periodic array of slits, or which we call it a grating, which usually we see in the periodic arrangement of atoms, like in crystalline atoms. So what we get is a central bright spot, then alternating layer of bright and dark spots. So the diffraction pattern is an interference pattern which is a combination of maxima and minima of interference. As we understood diffraction, now we will going to derive the famous Bragg's equations. So Bragg's equation, it is used for the diffraction in crystalline solid. In crystalline solid, there are the periodic arrangement of atoms. The atoms are present in planes as a planes of atoms, and let's say the distance between each plane is d. So as we know, diffraction can occur in a grating system. Here these planes of atoms, they act as a grating. So here diffraction can occur. For this purpose, let's put two X-ray incident beam which will be diffracted from the planes of atoms and emerges as a diffracted beam. So now the incident beam 1 and 2, these are parallel and coherent. They falls on P and Q points of atoms respectively and emerges as two parallel diffracted beam as 1 prime and 2 prime. Now let's draw a perpendicular from P to the line incident beam line to Q, and another perpendicular from P to the diffracted second beam line Q 2 prime. Okay. Now let's consider the triangle A, P and Q. So this is a right angle triangle. Okay. And let's the angle of incidence be theta. So if this angle is theta, the angle A, P and Q, it will be also theta. How? You see, the angle between two lines is same as the angle between their perpendiculars. Okay. So the line is 1 and P and the perpendicular is PA, and this line, it has a perpendicular with this. So the angle between these two lines is same as the angle between these two perpendiculars. I think that clears. Okay. Now the angle APQ is theta. So here sine theta will be AQ divided by PQ. Sin theta is AQ divided by PQ. And we know PQ is the interplanar spacing, which is equals to D, right? So sin theta equals to AQ divided by D, or we can say AQ equals to D sin theta. Now a similar process can be followed in the triangle B, P and Q. Here we will obtain BQ equals to D sin theta. Now let's calculate the path difference between the two beams. So the path difference between the two beams will be AQB, right? That is AQ plus BQ. So we have also calculated AQ and the value of BQ. Now the path difference is AQ plus BQ, which is 2D sin theta. Now according to Bragg's, they theorized that constructive interference occurs when the path difference is an integral multiple of the X-ray wavelength. Okay, so the constructive interference to occur, the path difference, that is summation of AQ and BQ, it should be an integral multiple of the X-ray wavelength, that is n lambda equals to 2D sin theta. So what did we get? N lambda equals to 2D sin theta. This is the Bragg's law for X-ray diffraction. So that means we will get constructive interference when this equation is satisfied. This equation holds the key for the diffraction analysis in crystalline solid, so which we will cover in future. Now some concluding remarks. X-ray diffraction is a really very powerful tool for crystallography. The crystal structure of material can be analyzed by X-ray diffraction, and Bragg's law is very useful for the analysis of X-ray diffraction patterns. These are the advanced level courses which we will cover in future classes. And again, the XRD can be used to find lattice strain, texture of material and some other purposes. So we can say XRD, that is X-ray diffraction, and Bragg's law, they hold the key for basic material characterization. Thank you.